Welcome to the rise of AI tools. Are developers being replaced? I'm going to walk you through how AI is really changing software development. What's hype, what's real, what the data says, and what it means for us as developers and engineering leaders. By the end of this session, you should have a clear, research-backed view of how to use AI tools effectively without losing control of quality, security, or your career. Let's start with the big, scary question. Are developers being replaced? AI coding tools have gone from curiosity to necessity in just a couple of years. According to Stack Overflow's 2024 developer survey, roughly three-quarters of developers already use or plan to use AI in their workflow. That's not fringe adoption, that's mainstream. Because of that, the discussion has shifted. We're no longer debating whether AI belongs in the workflow. We're now focused on how to use it effectively and for which tasks it actually excels. That's the key idea for this talk. We're not seeing a replacement of developers. We're seeing a transformation of the developer's role. On this slide, you can see how big this wave really is. First, on developer adoption. As I mentioned, most developers now use or expect to use AI tools. That's been confirmed by multiple surveys, not just Stack Overflow's. Second, enterprise integration. GitHub has reported that Copilot is now used by tens of thousands of organizations, including roughly 1/3 of the Fortune 500. That's huge. These are companies with strict compliance and security requirements who have still decided it's worth it. Third, standard tooling. AI is no longer a bolt-on experiment. Generative AI is becoming part of standard dev tooling baked into IDEs, CI pipelines, and even code review workflows. So, the AI wave isn't a future scenario. It's already baked into how modern software is built. When we say AI dev tools, we're talking about a few distinct categories that show up at different points in the workflow. Code assistance inside your IDE. Tools like GitHub Copilot, Cursor, or JetBrains AI. They suggest the next line of code, complete entire functions, and sometimes generate tests as you type. Chat-based helpers. Things like ChatGPT, Claude, Gemini. You paste error messages, legacy code, or an API description and ask, explain this, refactor this, or write me a snippet that does X. Agents and bots. More autonomous tools that can open pull requests to update dependencies, run code reviews, or draft documentation without being explicitly told each individual step. It's important to set expectations correctly. These are extremely powerful pattern matching systems, not junior developers with true understanding. They've learned from code patterns at scale, but they don't understand your product, your users, or your business context. Treat them as tools, not teammates with judgment. Practically speaking, here's how developers are using generative AI today. Drafting boilerplate, repetitive code CRUD endpoints, DTOs, configuration. Repetitive glue code is perfect AI territory. It saves time and reduces boredom. Code translation. Moving code from Python to JavaScript, from React to Vue, or from class-based to functional style. AI is very good at these mechanical but tedious transformations. Testing and refactoring. Developers ask AI to write unit tests, suggest edge cases, or refactor a messy function into something more readable. It's like a fast, always available reviewer. Understanding context. You paste a cryptic stack trace or a weird legacy function and ask, what is this doing? Or why is this breaking? AI can summarize unfamiliar libraries and generate documentation-ready explanations. Design exploration. Before you commit to a design, you can ask AI for alternative architectures, patterns, or trade-offs. It's like brainstorming with someone who's read most of GitHub. In all of this, notice the pattern. AI handles repetitive or exploratory tasks, so humans can focus on decisions, trade-offs, and real problem solving. Now let's talk evidence, not vibes. A controlled study run by Microsoft and GitHub took two groups of developers. One group used GitHub Copilot, the other didn't. Both groups had to build the same HTTP server. The Copilot group finished the task about 56% faster on average, with a slightly higher success rate. That's not a small optimization, that's a step function change. GitHub's own internal analysis of real-world usage has found improvements like faster time to merge on pull requests and higher developer satisfaction, especially for repetitive tasks. And in broader industry research, McKinsey has estimated that generative AI could improve software engineering productivity by 45%, with some tasks taking up to half the time when AI is involved. The takeaway is simple. Across multiple independent studies, AI tools consistently show significant productivity gains, especially for well-scoped coding tasks. They don't magically design systems for you, but they massively accelerate the implementation work. Here are the AI's sweet spots. Boilerplate generation. Whenever code follows a recognizable pattern, CRUD, standard API wrappers, config scaffolding AI, excels. It's pattern matching at scale. Rapid exploration. Show me 3 different ways to implement this pattern. AI is brilliant at generating multiple alternatives quickly, which you can then filter and refine. Test creation. AI is great at writing first draft unit and integration tests. It can often cover the obvious happy paths and basic edge cases faster than you could type them. Translation. Both human languages and programming languages. Comments, docs, code between languages, even between paradigms. Very useful if you're migrating or integrating with unfamiliar ecosystems. Always on assistant. It doesn't get tired, doesn't get bored, and doesn't mind answering the same question 5 different ways. For debugging, learning, and quick explanations, that's very powerful. In other words, AI is fantastic at high-volume, pattern-heavy work. That's where you should lean on it hardest. Now the other side of the coin, where AI is weak, incomplete, or ambiguous requirements. If your prompt is vague, AI doesn't push back or ask clarifying questions the way a human would in a real meeting. It happily makes things up to fill the gaps. Architecture and system design. Complex architectural decisions need deep understanding of constraints. Team skill set, compliance rules, performance targets, existing systems. AI can list generic options, but it can't weigh the trade-offs like a seasoned architect. Domain-specific constraints, regulatory requirements in finance or healthcare, weird hardware limits in embedded systems, opaque legacy dependencies. These are extremely specific. AI doesn't understand them unless you spoon-feed context. And even then, it's guessing. Long-term maintainability. AI optimizes for works now and looks plausible, not for clean boundaries, clear abstractions, or low technical debt. That's on us. True business and user context. AI doesn't understand why your system exists, who your users are, or what's at stake if it fails. It's pattern matching, not product thinking. So the rule here is, AI is powerful, but context blind. Anything that requires deep understanding of people, business, or long-term consequences still belongs firmly in human hands. This is the part we absolutely cannot ignore: security and quality. Multiple studies have found worrying patterns in AI-generated code. For example, academic work and security labs, including reports from organizations like CSET and Veracode, have shown that AI frequently introduces insecure patterns. Things like missing input validation, hard-coded secrets, outdated cryptography, and unsafe defaults. Some systematic tests have found that a large fraction of AI-generated snippets contain vulnerabilities serious enough to be flagged by standard security tools. There's also the feedback loop problem. AI tools generate code That code gets pushed to GitHub. Future models train on that code, and insecure patterns risk becoming normal in future generations of AI. And don't forget model-level risks. Prompt injection and data poisoning can trick AI tools into suggesting harmful code or leaking sensitive information if you plug them directly into internal code bases without guardrails. What does this mean practically? It means AI-generated code deserves at least the same and often stricter review standards. They must be treated as code from a junior developer. You assume it might be wrong or insecure until proven otherwise. Speed is great. Speed plus rigorous review is non-negotiable. Here's the human reality. Developers love the speed, but they don't fully trust the output. Recent surveys show that while adoption of AI coding tools is very high, often quoted around 80% and above developers using or planning to use them, almost half of developers say they don't fully trust the accuracy or safety of AI-generated code. Many also report that they've lost time debugging AI-written code that looked correct initially, but failed in edge cases or under real-world conditions. So we do have a trust gap. Adoption is high because the productivity boost is obvious. Skepticism is also high because people have seen AI hallucinate, oversimplify, or quietly introduce bugs. The healthy stance is AI is a powerful accelerator, not an authority. We should trust AI enough to let it help, but never so much that we stop reviewing and thinking critically. Now, from an economic and historical perspective, will AI actually replace us? Look at the history. In 1960s to 70s, assembly to high-level languages era, moving from raw assembly to languages like C massively increased developer productivity. Did we need fewer programmers? No. Software became cheaper to produce, so we built more of it and needed more developers. In the 90s, towards end of 20th century, IDEs, frameworks, libraries, Visual Studio, Eclipse, Rails, Spring, these tools abstracted tons of complexity. Again, they didn't kill developer jobs. They expanded what a single developer could build and increased demand for software. In the 2010 cloud, CI, divided by CD automation, infrastructure automation, containers, and managed services reduced operational toil. The outcome? Explosion in online services and startups, and more developers needed to build, integrate, and maintain them. And in 2020s, rises the generative AI assistance. Generative AI is the next productivity frontier, and research from firms like McKinsey suggests the same pattern: more productivity per developer, more demand for software, and thus continued or increased demand for skilled engineers. Historically, every major automation wave in software has increased, not decreased, the overall demand for developers. The skill set evolves, the role doesn't vanish. There's no solid economic evidence that this wave will behave differently. Even with very advanced AI, there are categories of work that clearly require human developers. Requirements translation. Turning messy business goals into clear, testable technical specs is a human conversation game. It involves negotiation, trade-offs, and understanding politics, constraints, and priorities. Architectural design, choosing how systems fit together, what's a service, what's a module, how data flows, what failure modes to plan for, that's deep engineering judgment. Trade-off decisions. Security versus speed, cost versus reliability, UX versus implementation complexity. These decisions are tied to business outcomes and risk appetite. AI can enumerate pros and cons. It cannot own the decision or the responsibility. Production debugging. When something explodes in production at 2 a.m. with weird, non-reproducible bugs, it takes intuition, past experience, and creativity to triangulate the cause. AI can assist, but it doesn't own the incident. Ethical judgment, decisions around data privacy, fairness, and abuse prevention require values and accountability. That is not something we outsource to a pattern matcher. These are exactly the areas where experienced developers and engineering managers are irreplaceable. AI can assist, but it can't be accountable. This is the realistic division of labor across the lifecycle. In requirements phase, AI can help brainstorm user stories, edge cases, and acceptance criteria based on a problem statement. Humans validate what actually matters and what aligns with business goals. In the design phase, AI can suggest architectures or patterns, layered architecture, event-driven, microservices versus monolith, and so on. Humans pick and adapt the design based on real constraints, team skills, existing systems, compliance, SLAs. During implementation, AI drafts code. Humans integrate it, refactor it, and ensure it fits the style, structure, and constraints of the codebase. In testing phase, AI generates test cases and even code for tests. Humans define coverage strategy, add critical edge cases, and interpret failing tests. In deployment, AI can help write infrastructure as code snippets, pipeline configs, and deployment scripts. Humans own when, how, and whether to deploy. While in operations, AI summarizes logs, metrics, and alerts. Humans interpret impact, make remediation decisions, and decide what structural changes to make. So across the workflow, AI accelerates, but humans direct. That's the partnership model. Think of AI as your always available pair programmer. To get the most out of it safely, provide context, don't just say, fix this. Paste the relevant files, error messages, and constraints. Mention your language version, framework, and architectural rules. The more context you feed, the better the suggestions. Ask for explanations. Explain why you chose this approach. Walk me through this code. Good AI tools can narrate their own output. That lets you quickly check if the reasoning matches your reality. Treat output as suggestions. AI is not a senior engineer. It's a suggestion engine. Treat its output like a code sample from the internet. Useful, but always subject to your review and modification. Enforce review and tests. Make it a policy that all AI-generated code goes through normal human code review and automated tests. No exceptions, just because the AI wrote it. Track AI contributions. Tag AI-generated code in commit messages or PR descriptions. That's useful for audits, debugging, and understanding where you may need extra attention later. If you follow these practices, AI becomes a force multiplier, not a silent source of bugs. Now let's zoom out to workflow design, risk-based strategy. Use AI aggressively, where risk is low internal tools, non-critical features, documentation, tests. Use it cautiously or not at all on security-critical or safety-critical paths unless you have strong review and testing in place. Combine analysis tools, run AI-generated code through your existing tool chain. Linters, type checkers, static analysis, SAS tools. Security vendors like Checkmarks and others are already recommending exactly this pattern for AI code. Build guardrails? Add rules to your code style guide and linters specifically to catch common AI mistakes. Banned APIs, insecure patterns, unsafe defaults. Make it easy to reject bad AI code automatically. Continuous monitoring. Track vulnerabilities, incident causes, and defect patterns. If you see a spike in bugs tied to AI-written modules, adjust your process. The data should guide how aggressively you use AI. The short version: AI first doesn't mean safety last. You can be both fast and safe if you design the workflow consciously. This is how our own skill set needs to evolve. Prompt engineering. You don't need to be a prompt engineer as a job title, but you do need to know how to structure inputs, give context, define constraints, specify style, and ask for step-by-step reasoning. Rapid code critique. In an AI world, you spend more time reviewing code you didn't write. You need to get very good at quickly spotting logical gaps, security issues, and design smells in AI output. Stronger foundations, algorithms, data structures, concurrency, security, basics, these matter more, not less. They're what let you see when AI is doing something subtly wrong. System design thinking. As AI handles the micro level, humans need to be stronger at macro level system design, understanding end-to-end flows, failure modes, and long-term maintainability. Communication and product sense. You'll spend more time talking to stakeholders and coordinating humans plus AI. Being able to explain trade-offs and align with product goals is a major differentiator. The developers who thrive will be the ones who combine deep technical competence with the ability to leverage AI intelligently. Let's make this very concrete. Differentiate between the good use cases and the riskier spots. Good use cases for AI. Non-critical migrations. Migrating an internal tool to a new framework or language? Let AI do the first pass, then you review and fix. Unit test generation. AI can quickly draft a large set of tests. You curate, fix, and add edge cases. Huge time saver, low risk. API documentation and comments. AI is great at summarizing code into human-readable docs. You just correct and refine details. Boilerplate CRUD for internal tools. Standard operations that follow known patterns are perfect for AI. Easy to verify, low blast radius. Risky use cases for AI, security and financial code, authentication, authorization, cryptographic routines, payment logic. These must be treated as high risk and written or deeply reviewed by experts. Unfamiliar frameworks. If you don't know the framework, you can't safely judge whether the AI is doing something dangerous or just wrong. That's risky territory. Complex business rules. Eligibility rules, tax logic, domain-heavy workflows. AI will oversimplify or misinterpret details. Humans need to own these. Performance-critical hot paths. Code that runs millions of times per second or drives latency-sensitive workflows needs careful human optimization and profiling. So the rule of thumb: use AI where verification is easy and consequences are small. Keep humans in the driver's seat where complexity, risk, or nuance is high. This is the team-level strategy. Define clear policies. Write down how your team uses AI, where it's allowed, where it's restricted, and what review is required. Make it part of your engineering playbook. Add traceability metadata. Tag AI-generated code in commits and PRs. That makes audits easier and helps you correlate bugs or incidents with AI usage. Train on AI literacy. Don't assume developers will just figure it out. Run internal sessions on how the tools work, where they fail, and how to prompt and review effectively. Measure impact continuously. Track metrics like cycle time, defect rates, and incident causes. Ask, is AI actually helping? Where is it hurting? Use hard data, not gut feeling. Iterate and improve. Treat AI adoption as an ongoing experiment. Adjust policies, tools, and training as you learn. Don't lock yourself into the first setup you try. Successful teams don't just install Copilot. They intentionally redesign their workflows for an AI-augmented world. Time to answer the initial question clearly. Are developers being replaced? From coders of lines to designers of systems, AI changes how we write code, but not why we write it. Our purpose solving real human and business problems doesn't go away. We just operate at a higher level. This is augmentation, not replacement. Research and real-world adoption data show that we're seeing augmented developers, not obsolete ones. Productivity increases, scope expands, and demand for skilled engineers remains strong. Time to orchestrate. Don't blindly rely. The developers who will thrive are those who can orchestrate AI across the lifecycle requirements, design, coding, testing, operations while still owning the decisions in the quality bar. Think partnering for better software. This isn't AI instead of developers. It's developers plus AI. When you combine human judgment, creativity, and accountability with AI's speed and pattern recognition, you get better software faster. So no, developers are not being replaced. Developers are being upgraded if we choose to adapt. To close, this isn't a one-off conversation. AI in development is evolving quickly, and the best thing you can do is keep learning and experimenting deliberately. The future belongs to developers who combine deep technical knowledge with the ability to use AI as a force multiplier. Check out the Genius Circuit at thegeniuscircuit.com. You'll find resources on generative AI, practical tool usage, free learning materials, not just for developers, but for everyone. Embrace the change. Take this away as your core belief from this talk. So keep your fundamentals sharp, build your AI skills, and design workflows where you and your tools work together. That's how we build the next generation of great software.